Hello, this is Professor Jakovich, and we're going to be computing how much should you save now so that you can retire at the age you want to and have enough money to live on. So, there's a few things that you need to know to start, and we're going to use Jane here as our young person who wants to retire. She's 25 years old. She would like to retire at 60 years old. And here's the tricky part. You have to figure out how long that money needs to last you. So you basically need to know, when are you going to die? Well, if you're female, you're going to look at your mom's life expectancy, her sisters, your mom's mother, your mom's mother's sisters, everything on your maternal side. If you're a guy, you'll look at your paternal side and all the guys over on that side for your best estimate of when you think you're going to leave this world. Then you're going to add 5 years to that age because technology improves, and what the heck, let's be optimistic anyways. You don't want to outlive your funds. So in this case, Jane thinks that on average, the ladies in her family die at about 88, and so she put 93 here. She added 5 years to that. Also, she has absolutely nothing saved up to put towards this, so she's starting from scratch. And I think I said she'd like to retire at age 60. So I drew a timeline that shows starting right away at 25 years old with $0, and then there's a mark for 60 years, which is when she'd like to retire, and then when she expects to croak. So there's a few things we have to do. We have to compute how many years from now till retirement and how many years from retirement to death. And so essentially what we're looking at here is 35 years from there to there. And over here, we're looking at 33 years. That's how long her money needs to last her. So we are going to be doing two present value style equations to come up with the payment that we need to pay every month from now till age 60 to be able to live comfortably after that. Well, pre-retirement, what do we know? We know that the present value is 0 because she has nothing. If she had money, $10,000, then the present value would be $10,000. But she has nothing. So we're going to put 0 there for pre-retirement. For her future value, we don't know what that is. That's a big question mark because the future value is how much does she need at age 60? The payment, we have another question mark. That's actually what we're trying to solve for. How much should she pay out every month to make sure that that future value at age 60 is big enough to last her 33 years? So we have 2 question marks. Not good. You can't solve an equation with 2 question marks. Number of periods. Now, I said she's going to put money in every month. So we cannot use years. We have to convert everything here that's highlighted to a monthly amount. So the number of periods would be 35 years times 12 months per year, which actually ends up being 420 months. We will need to do the same thing over here, and this ends up being 369 months out here. That's how long her money has to last her. So that's been converted. Number of periods are 420 here. Monthly periods post-retirement, we just computed it, might as well fill it in, 369. And the rate, that was a given. I gave that here and here. Pre-retirement, she is going to get 10%. However, we need a monthly rate. All rates are given annually. It's just how it's done. APR, annual percentage rate. So 10% is an annual rate. So our monthly rate, there's no sense doing the math. Excel will do it for you. 10 divided by 12. And post-retirement, we're going to move things into safer investments. So it'll be 5 divided by 12 to get a monthly rate for that as well. Now, what else do we know? We know, based on this given, that you're going to take monthly withdrawals of $6,000. So the payment post-retirement is negative because it's an outflow. It's money coming to us, is negative $6,000. What is the future value? Well, we're going to have a chunk of change here that we don't know how much it is now, but when we work the second half of this problem, this half here, what was the future value for pre-retirement becomes the present value for the second equation. This right here is your present value, still unknown. But the future value is 0. She's gonna spend it down to nothing. Now, what if you wanted to leave $8,000 for your nephew? Well, then you'd just put a future value of $8,000. But she doesn't want to leave anything to anybody. She's a kid, and her parents she expects will be long gone by the time she's 93. And she doesn't have any kids, so she's like not thinking about leaving people money. But if she wanted to, she would put it there in that future value amount. So now it's just time to do some math. And here we go. We have to solve the second half first, because guess what? There is only a single unknown in this half here, and it is the present value. So we're going to solve for that present value as soon as So we're going to say equals PV, open parenthesis, and then it tells me put in the rate. Well, the rate is 5 divided by 12. When you do that, you have to put 5% / 12 before you put your comma. Do not put the percent after the 12 or you're going to get an error. Excel just likes it this way. That your rate is 5%, and then you take that 5% and you divide it by 12. So then the number of periods, 369, put your comma. The payment, negative 6,000. Do not put a comma after the 6 in this number. Excel will read it as 2 different numbers, a negative 6 and a bunch of zeros. Then we get to future value. That is 0 in the case of Jane. And then we can just close it out and hit enter. Look at that figure. We have to save up $1,129,000, $528.33 for it to last 33 years at 5% a year, taking $6,000 out a year. So this number here goes in this big dollar bag and becomes our future value for the second half of the problem. So I'm going to delete that little question mark and say that this equals that. And now we know our future value, and we have only one question mark, and that's the payment, what we're trying to solve for, which is, in Excel, you always say equals, and then what you're trying to find. We're trying to find the payment, PMT, open parenthesis. The first thing it wants is the rate. And again, we have now 10 divided by 12. But remember what I said, 10% divided by 12, comma. And number of periods, 420. Then the present value is 0. The future value is, no commas now, 1129528.33, and we can close out and look at that. For you to have $1.1 million in 35 years, you have to put away $297.51 every month, starting now at 10%, which is not hard to get at all in the stock market. Quite often you'll do better than that. So $300 a month. Can you do that? You probably can. Now let's say one change. Let's say that somewhere along here, you're 25 years old and your grandmother said that when you turn 40 years old, she's going to give you $10,000. Well, that's 15 years from now. So what would we do? How would that change things? All right. We know that right here, that's probably the wrong place, but pretend that's age 40. At age 40, you're going to get $10,000. All right. Before you can solve for pre-retirement now, you've already solved for this when you did post-retirement. Your future value is 1129 still. However, you get to figure out a lump sum equation. What will $10,000 be worth in 20 years? And then guess what? When you figure out what it's worth in 20 years, you can subtract it from this amount because you don't need to save that much. You get to save that much minus whatever this $10,000 adds to it. So, how do you do a lump sum problem? Let's see, pens. There, you're going to say, we want the future value equals, we want to know what that 10,000 will grow to. The rate at this point is still 10%. So 10% divided by 12. Everything needs to stay at the same amount. 10% divided by 12. The number of periods is 20 years times 12, which is 240 months. Payment is 0. We're not doing a payment. We just have a lump sum. Then the present value is $10,000. And we can close that out. All right. This $10,000 that Grandma is going to give us is worth $73,000. You can reduce this pile of money of $1.1 million by $73,000 now. And then you change this. Then your pre-retirement amount, your payment will change, if that makes sense. Because now you don't have to save $73,000 of this future value. So reduce this future value by that amount and solve again for payment. And you'll find out that you have to save even less than $297 a month. So there you go. There's all sorts of things you can do with these computations. Just change the numbers and figure out what works for you. Have a great day.